All right, let's continue with part B. So I have the integral from 0 to power 2, secant x dx. So I have the interval of integration to be 0 and power 2, and this doesn't involve any infinity in any of those limits. That's good. However, secant x is not continuous on the interval of integration. And you can see that if you want to write this as like 1 over cosine x, because secant and cosecant are reciprocals of each other. So as you see that in the right limit at power 2, cosine becomes 0, and this becomes 1 over 0. So secant pi over 2, in other words, blows up to infinity. And I want you to see it, and please have your TI-84 with you, and you can pause the video at this moment. And what I want you to do is to plot secant x from 0 to pi over 2 with x min to be 0, x max to be pi over 2, and plot secant x. And you will see that at pi over 2, we have a vertical asymptote, and the integral that we have here, the integral from 0 to pi over 2, secant x, is this infinite area. Because when you have a vertical asymptote, now you have this area going all the way to infinity, even though it's teeny tiny. We don't know if this total area, the green area, is going to be a finite number or infinite number. So we don't know that. We have to do analysis here. So we have to evaluate this integral carefully. So let's just do that. But obviously, we are going to use the recipe that we had earlier. So we have the upper limit having a problem. So that means this b, let me just clean this b here, the upper limit, having a problem here. What I'm going to do is I'm going to switch that to c, so that I have a definite integral from a to c, but then I'm going to take the limit as c approaches b from the left. Okay, so let's apply this strategy to this problem here, so that this integral turns out to be limit as b approaches pi over 2 from the left. Okay, integral from 0 to b, secant x dx. Okay. Normally, we take a separate space to integrate the integrand, right? Or find the antiderivative of, let's say in this case, secant x. But secant x is one of the elementary functions, and we have a formula in the integration formula card to take care of the antiderivative of that. In fact, the antiderivative of secant x is ln secant x in the absolute value plus tan x. Okay, so we can right off jump into the fundamental theory of calculus. Okay, so now let's plug in the upper and lower limits by keeping the limit operation outside. Okay, so this is ln secant b plus tangent b, right? That's me plugging in the upper limit. Minus, I'm plugging in the lower limits. Okay, so that's ln secant 0 plus tan 0, right? And go ahead and use your TI-84 to get the exact values of secant 0 and tan 0, okay? And put it in the radian mode before doing that, obviously. So this is 1 and this is 0. So this whole thing is ln 1, which is 0. Okay, so there's the contribution coming from the lower limit in calculating the antiderivative. And so let's do this. Let me just save more space here. So limit as b approaches pi over 2 from the left. Okay, this ln, I don't need a bracket anymore, so all I'm going to look at is the limit for secant b plus tan b. Okay, we already have the graph of secant b, and we already know that secant b approaches infinity as b approaches pi over 2 from the left, as you see, because pi over 2 is a vertical asymptote and it shoots off to plus infinity. And go ahead and plot the tangent, and you will deduce the same thing, that on the left of pi over 2, tangent also shoots off to infinity. So this whole thing becomes ln infinity, and ln infinity is also infinity. You can graph ln x for large x's, you will see that it approaches infinity. So this is this value of the limit is just infinity. That is in fact the value of the improper integral. Okay, so going back to my original question, is the area finite or infinite? Well, turns out that this area is infinite. So the area is infinite. Okay, so it diverges, right? So integral diverges, but the area becomes infinite. All right. I think that takes care of part B. Please move on to my next video to see what I'm going to say for part C.